and welcome to APE in Berlin, Germany. My name is Rita, and in the next few minutes I'm going to show you some of the advanced features of your pulseCheck autocorrelator. Now, in order for you to take measurements, we first need to make sure the polarization of your incoming laser beam is correct. By polarization, we mean the form of the light waves generated by your laser system. Different systems produce different types of polarization. What's important to know is pulseCheck needs horizontal polarization to take its measurements. If your laser only produces vertical polarization, don't worry, you can switch it to horizontal by using a polarization rotating periscope. Just place the periscope along the incoming beam path, then adjust the mirrors as needed to properly direct the beam. This will turn the light polarization to horizontal. When you set up pulseCheck, you needed to align the incoming beam. That required us to set pulseCheck to collinear mode. But to optimize your measurements, we now have to set pulseCheck to non-collinear mode. Let me show you the difference. In collinear mode, both output beams overlap before they reach the crystal. That was useful during setup, because it let you align the incoming laser path by only focusing one beam in the crosshair. But collinear mode produces a lot of interference and background signals. By switching to non-collinear mode, both output beams no longer overlap at the detector and crosshair. Now they only overlap in the crystal. The result is a background-free SHG intensity autocorrelation signal. And switching to non-collinear mode is easy. You can do it by turning a single micrometer screw, located here. As you turn the screw, you'll begin to see two beams in the crosshair, and your controller screen will start to show a clean measurement signal. Keep turning until the signal is perfectly smooth and background-free. To optimize the signal, turn the focus screw. Next, let's talk about how to change the optic set. pulseCheck makes it easy to change the optics whenever you like, such as when you want to measure another wavelength range. Let's start by replacing the crystal module. Switch off the controller unit, block the incoming laser, then remove the cover. Remove the crystal by gently pulling on it. Then insert your new crystal into the slot. Turn the crystal until the pin snaps into place. Then replace the cover. In our basic setup film, I showed you how to check and replace pulseCheck's detector unit. Now I'll take you one step further by showing you how to replace the photomultiplier tube that attaches to the unit. First, remove pulseCheck's top lid. Pull the retaining clip back and lift the detector out. Then unplug the connector. To move the photomultiplier tube to a new detector unit, simply unplug the tube, like this. Then line up the pins with the unit you want to install, and snap them together. To install the new detector, plug in the connector, slide the unit into place, and listen for the click of the retaining clip. Then secure the lid. Okay, the last feature I'd like to show you is trigger mode. It's something we specially built in for customers using low repetition laser systems. First, connect a BNC cable to the trigger input jack on the back of pulseCheck. Connect the other end of the cable to the output from your laser system. Now go to your controller unit and select the main menu. Then select Acquisition and change the setting from free run mode to trigger mode. The display should confirm you're now in trigger mode, so you can be sure your measurements will be totally accurate. And there you have it. I hope I've been able to help you get started. You'll find a full list of features in your manual. And if you have any questions, our support team is always ready to help. On behalf of everyone at APE, thanks for watching. Bye for now.